Hello students, welcome to Narayan PU College online classes. So in the last video we have discussed about physical properties. We have completed 6 physical properties in the last video. So the first one is physical state, and the second one is, that first one we have discussed about the physical state, and the second one we have discussed about the atomic and ionic radii. Third one is ionization energy. Fourth one is electronegativity, melting and boiling points. So this we have completed in the last video, and now we will discuss about oxidation state. Clear ma? So next one is oxidation states. Clear? So now the elements of 15th group will show both the positive and negative oxidation states. Clear ma? So most of the main the oxidation states, main oxidation states exhibited by the 15th group elements are, what are those is -3, +3 and +5. These are the oxidation states mainly exhibited by the 15th group elements. Clear? Both positive and negative. Clear? And you know that here, what is the +3, what is the -3, +3 and +5? And the general electronic configuration you already know, ns2, np3. So here means 2 electrons are there in the s orbital and 3 electrons are present in p orbitals. Clear? Now, if these 3 electrons loses, then what the positive oxidation state you will get? +3, losing of 3 electrons, +3. Suppose losing of total 5 electrons, +5. And now you know that some elements, highly electronegative elements, they can gain the 3 electrons to get the fully filled p orbitals. Gaining 3 electrons means which charge? You will get the -3 oxidation state. Clear no? So these are -3, +3 and +5 oxidation states. Clear? And now in this case, this -3 oxidation state mainly exhibited by nitrogen and phosphorus. Mainly exhibited by which one? Nitrogen and phosphorus. To exhibit the -3, to show the -3 oxidation state, it has to gain the electrons. How many electrons it has to gain? And 3 electrons should be gained. Clear? So means to gain electron, the element should have the high electronegativity. So that's why here -3 oxidation state. Clear ma? It is exhibited by it is shown by, clear ma? Shown by which one ma here? Nitrogen and phosphorus only. Clear? And remaining elements, they will not show the -3 oxidation state. Clear? And the remaining all elements means phosphorus, arsenic, antimony, bismuth, they shows the +3 and +5 oxidation state. Clear ma? +3 and +5 oxidation state. Clear? Oxidation states. Clear ma? And you know that here, whenever when you are moving from the you see here oxidation state, stability of oxidation states. Clear? And +5, the stability of +5 oxidation state decreases down the group. +5 oxidation state decreases the which one here? Down the group. Why it decreases down the group? Because you already know that inert pair effect. Clear ma? First I will write the points, then we will discuss. And +5, the stability of, what it is ma here? Stability of +5 oxidation state. +5 oxidation state decreases down the group. Down the group. Decreases down the group. Clear ma? So why means you already know reason. And down the group, increasing in the inert pair effect. Yesterday I have already discussed what is the inert pair effect. Clear ma? So this is because of which one ma here? Because of are due to increase inert pair effect. Increase inert pair effect. Inert pair effect increases which one? Down the group. Clear? And you know, when inert pair effect increases, inert pair means what it is? The nucleus will hold the s electrons tightly, so that's why they will not participate in these s electrons. You know, this is, you know, ns2, and here what it is there, np3. Clear? If you are moving down means nitrogen to bismuth. If you are moving, you know that, and down the group automatically d and f orbital will come. When d and f orbital will come, they will show the poor shielding effect. When they show the poor shielding effect, the nuclear force on the outermost electron will be very, very high. So that's why the nucleus holds this s electrons very tightly. So these s electrons, it holds very tightly means we cannot remove these s electrons. So how many electrons can be removed here? 3 only. So that's why, and stability of +5 oxidation state decreases down the group because of increasing the inert pair effect. Clear, ma? And now if you see here, +3 oxidation state, stability of +3 oxidation state increases, you know, from nitrogen to what it is, here, bismuth. So that's why you know that bismuth, if it is there in +5, means bismuth is making 5 bonds with the atoms, it is unstable. Clear, ma? So that's why we know that. Clear, ma? So bismuth, if you take bismuth Bi5, or you can take here bismuth is attached to the 5 atoms. Clear? So here suppose, you know, Bf5 is there, it is existed, but you know that this Bf5 compounds are, you know, Bf5 compounds are unstable. Bf5 compounds are which one, here? Unstable. Why? Because of inert pair effect. Bismuth, instead of showing the +5 oxidation state, which oxidation it will show? +3. So that's why, and you know that this is unstable. But you know, Bi+3 ox compounds are, you know, compounds are which one, here? Stable. Compounds are stable. Clear, ma? So now, so that's why if you see here, element and oxidation state. Clear? Element and oxidation state. Clear? If nitrogen, you know that nitrogen, it can show the -3 and +3, and what it is there, +5. And phosphorus can also show the -3, +3, and what it is, +5. And arsenic, you know, it will show +3 and +5. Antimony, you know, antimony, it will show the +3 and +5. But bismuth is mainly +3. It will also show +5 only. Bif5 only the bismuth pentahalide compound, means +5 oxidation state and somewhat stable is this is only. Remaining, you know, bismuth pentahalides are unknown or unstable. Clear, ma? So this is, you see, as we are moving down the group, +5 oxidation state decreasing and +3 stability of +5 oxidation state decreasing and stability of +3 oxidation state increasing. Clear, ma? So this is now, and if you take this is just write a table like. Clear, ma? This is one element and oxidation state. If you write like this, then you will get the clarity. Means here +5 is there, +5 oxidation stability is keep on decreasing down the group from the nitrogen to bismuth. But if you see nitrogen shows and various oxidation states. Clear, because of its small size and high electronegativity, and nitrogen shows various oxidation states, that is from -1 to and +5 in various compounds. Clear, ma? So nitrogen shows here, and you see nitrogen compounds, here I will write compound. Clear, ma? And here oxidation state. This is only for which one? Nitrogen. Because nitrogen is small in size and high electronegativity, so that's why it can show the positive oxidation state and also negative oxidation state. But nitrogen will show the oxidation states from the -1 to +5. If you see the compounds, what are the nitrogen compounds? If I take this NH3, what is the oxidation state of nitrogen here? -3. If I take NH2, what is the oxidation state here? -2. You know how to calculate the oxidation state, I will not write here. So if you take NH3 and NH2, next one is if you take NH2OH, clear, ammonia hydrazine and hydroxyl amine. In this one nitrogen is -1. And now you know nitrogen elemental, this is 0 and N2O plus 1, NO plus 2, N2O3 plus 3, NO2 or you can say N2O4 plus 4 and 2O5. What is the oxidation state here? Plus 5. Clear? No? So this is what here? Nitrogen. Nitrogen shows, you know, different oxidation states from which one? -3 to +5. Clear? All oxidation state. I already mentioned here. Nitrogen, it will show the -3 oxidation state, +3 and +5. And in the between also, -2, -1 also it will show. Why reason means? The reason you have to write because of small size and high electronegativity of what it is, nitrogen. And the next one it is there. Disproportionation. Next one what it is here? Disproportionation. Disproportionations means disproportionation reactions. Clear? If you take here and nitrogen and the nitrogen, all the oxidation states from clear, -3 to or -1 to +4, -1 to +4. Clear? And they are means show disproportionation reactions, disproportionation reactions in acidic medium. In which medium here? Acidic medium. Clear? So means if any compound is having oxidation state from the -1 to +4, they will show the which reactions here? Disproportionation. They involved in the disproportionation reaction. One example I will write here. Take here HNO2. What is the compound here? HNO2, nitrous acid. What it is here? Nitrous acid. And now nitrous acid in acidic medium, and it will be converted into HNO3 plus NO plus what you will get here? H2O. Clear? So you know that here, and 3 molecule if I take and 2 molecule, then it will be balanced. You know that in this one, and this one is what is the oxidation state of this compound is +3, and here this compound is +5, and here what it is +2. The same element undergoing both the oxidation and what it is reduction. Here also what it is? Same element undergo oxidation and what it is here? Reduction. That what we will call? That we will call as a disproportionation reaction. So from where to where here? From oxygen, if it is having the oxidation state from the +1 to +4. Clear? +1 to +4. Sorry, I have written here -1. So +1 to +4 oxidation states are there, and they show the disproportionation reaction. In the same way, we can also write for the phosphorus. This is for nitrogen, and phosphorus also will show the disproportionation reaction. And phosphorus and all the oxidation state between, or you can say intermediate, all the intermediate oxidation states, clear ma? Oxidation states from of -3 to +5. -3 to what it means? +5 means if any compound is having oxidation state between the +3 to +5, and those compounds of the phosphorus will show the disproportion. There is a chance to show the disproportionation reaction. They show the which one here? Disproportionation. Suppose I will take here H3PO3, phosphorus acid, and it involved in the disproportionation reaction and gives the phosphoric acid, and you will get phosphine. Clear? So if you multiply this one and multiply this one with the 4, clear, and multiply this one with the 3 plus 1 4, and phosphorus are balanced. You see now here this is a phosphorus, it is there plus 5 and this is plus 3, and you know this is minus 3. Same atom undergoing positive and negative, all intermediate oxidation states of which one here? Phosphorus, of phosphorus, between phosphorus from minus 2 to plus 5. This is oxidation state. In middle means it is not minus 3 and not plus 3. Minus 2, minus 1 are up to plus 4. They show the, you know what it is here? Disproportionation reaction. And this is about the oxidation states of 15th group elements. So next property, 7 properties we have. 7th one is oxidation state and 8th one is density. Clear ma? So you already know about the how density varies in the groups and periods, and you know that density increases down the group and decreases, you know, increases down the group. That is the main thing. So that's why if I write the density, what is the order? Nitrogen, phosphorus, arsenic, antimony, and what it is here? Bismuth. This is the order of which one ma? Density. And next property is allotropy. Next property is what it is ma? Allotropy. What is meant by allotropy? Clear ma? The elements exist in different physical states. Clear? And that we will call as a allotropy. Clear? And mainly here except nitrogen and bismuth. But in the NCERT textbook they have given only except nitrogen, but bismuth also it is there. But if they ask in the competitive examination, you have to choose the option is nitrogen, because we have to follow the NCERT textbook. Clear ma? So here except nitrogen and bismuth, remaining all elements show the allotropy. Allotropy means what ma? They are, one element will be there, it will be available in different states, physical states, that we will call as a allotropy. So what it is here? Except nitrogen and bismuth. Except nitrogen and bismuth, remaining all elements shows the what is allotropy. And all elements except nitrogen and bismuth, all elements show what it is ma here? Allotropy. Clear ma? So I will write here element and here I will write allotrope. Clear ma? So what is the element here? Nitrogen will not show any allotropy, and phosphorus it will show various allotropic forms. It has various allotropic forms, but the main allotropies of phosphorus are, you know, red phosphorus. I am writing P only here, red phosphorus, and next one is red phosphorus, white phosphorus, and black phosphorus. These are the very important, you know, what it is ma here? Allotropy forms of phosphorus. And now next one is arsenic and antimony. Arsenic and antimony, they are available in yellow state and what it is ma here? Gray. Allotropic form of phosphorus are here what it is ma? Yellow allotropic form and gray. Clear ma? And same on phosphorus, antimony also will show the allotropy is what it is ma here? Yellow and gray. So you know that here bismuth will not show any allotropic form. Clear ma here? So this is about the allotropy of which one ma here? 15th group elements. Clear? And if you go for the next one is here atomicity. What is the next one here ma? 9th one. 10th one is atomicity. Clear? You know that nitrogen is a diatomic molecule. What it is here? Nitrogen is a diatomic molecule. And next one is here, you know, arsenic, nitrogen, phosphorus, arsenic and antimony are tetraatomic molecules. So tetraatomic molecule. Clear ma? So what is the nitrogen atomicity means? What you have to write? 2. What is the atomicity of the, you know, phosphorus, arsenic, antimony means here 4. You know that bismuth, it will be, you know, it will form the metallic bonds. It will be exist in, you know, tetratomic and also sometimes in different forms. Clear? This is about the atomicity. Clear? And next one is here nature of bonding. Last property here, nature of what it is here, bonding or covalent bond. Nature of covalent bond. Nature of covalent bond. This is the another one. Clear? You know that if oxidation, the compounds of 15th group elements in +5 oxidation state are covalent in nature. Clear? So what it is here? Compounds of +5 oxidation state. If compounds of the 15th group elements are there in the +5 oxidation states, and those are what it is here, covalent. Those are which one covalent. Why? Because according to the Fazan's rule, you might have studied in the what it is first year. And what is the Fazan's rule means? For the covalent bond, for the what it is covalent bond. So what is the requirement here? Cation should be small. Cation should be what it is here? Cation should be small. Clear? And second one, anion should be large. Anion should be large. And third one is charge should be very high. Charge is high, then these are main important 3 points. And if charge is high, then this that compound, it forms the covalent bonds. So that's why here nitrogen, what is the highest oxidation state of the 15th group elements here? +5. Whenever they are having here highest oxidation state, means charge will be very high. If the charge will be very high, they will form only covalent compounds. These all are which one here? Covalent compounds. But whenever they are in +3 oxidation states, the compounds of 15th group elements in the +3 compounds of 15th group element will show the both the covalent and ionic, both the covalent and what it is here, ionic. Clear? And if I take here, suppose mainly suppose NCl3 I have taken here, PCl3, these all are which one covalent. ASCl3, these all are what it is here, covalent. But if you take BiCl3, clear, and SbCl3, and these are ionic. Clear? That's why here the compounds of +3 oxidation state of the 15th group element, they show the both the characters, covalent character and ionic character. Means you see down the group, what will happen here? Ionic character increases and covalent character decreases. Why ionic character means that in this case charge should be, means ionic means in the reverse case, exactly reverse. Cation should be large, anion should be small, and charge should be less or small. If you are moving from the top to bottom, the oxidation state, the stability of oxidation state decreasing. And I already said bismuth mainly will show the +3 oxidation state. So bismuth is +3 oxidation states means that automatically they are in ionic form, or otherwise you can simply say here what is that. And nitrogen to bismuth, as we are moving, the central atom is cation size is increasing. Cation size increases, ionic compounds means cation size should be small, covalent compounds. And for the ionic, cation should be which one? Large. And anion should be what it is here, small. Anion should be small. Clear? And charge should be what it is here, charge should be low. Clear? Now as we are moving from the NCl3 to BiCl3, cation is, how this will be converted to Bi plus and 3Cl minus. 3Cl minus. Clear? So what is the charge here? From here nitrogen to phosphorus, cation size is increasing. Cation size increases means which compound it will show? Ionic compounds. Clear? So that is, and next one is nitrogen and phosphorus. Nitrogen and phosphorus forms only covalent compounds. Forms only what it is here? Covalent compounds. Forms only covalent compounds. Clear? In whether it is in +5 state or in whether it is in +3 oxidation state, nitrogen and phosphorus only forms which compounds here? Covalent compounds. And this is about the physical properties of 15th group elements. Next one is anomalous properties of nitrogen. Clear ma? So if you see the 15th group to 17th group, the first element in all groups behaves differently from the rest of other elements. Clear ma? So here if you take the 15th group elements, the first element what it is here? Nitrogen. Nitrogen and differ from the rest of the other elements. Rest of the what it is ma? Other elements. So what is the difference and why it will show the difference from the means different behavior from the other elements of the same group? Clear? That we have to discuss. So very important question. This is for PU examination. Clear ma? For 2 marks most of the time this question is asking. Clear ma? So what they are asking, and the nitrogen will show the means write the anomalous properties of the nitrogen, they will ask. Clear? So first of all we have to write why nitrogen behaves differently from the other elements means because of 4 reasons. Clear ma? So what are those 4 reasons means? The first one is here because of its small size. Because of its what it is ma? Small size. And second one is here, and the second one because of high ionization enthalpy, high ionization energy or enthalpy. Clear ma? Third one, high electronegativity, high electronegativity. And fourth one is absence of d orbitals. Absence of d orbitals. These are the main 4 reasons why means nitrogen behaves differently from the other elements. Clear ma it is? So because of its small size, high ionization energy, high electronegativity and absence of d orbital. You know that and 15th group to 17th group the first elements will not have the d orbital, because you know, suppose if I take the nitrogen, what I can write now here? 1s2, 2s2, 2p, 2. Clear ma? So means in this second orbit, this is the first orbit, you know, this is first orbit and this is second shell. So you know that d orbital starts from the which shell? Third shell. Clear ma? So 1s2, 2s2, 2p6 and 3s2, 3p6 and 3d will come. 3d means which orbit it will be? In the third. But nitrogen is present up to the which orbit? Second orbit. So that's why nitrogen doesn't have the what it is ma here? D orbitals. Clear? So now, and you know, and which properties nitrogen and behaves differently? What are those properties? Clear? And in which properties nitrogen shows differences with the other elements? That we have to, but in the examination you have to write these 4 points only. Clear ma? So here properties which nitrogen differs. Clear ma? So here properties which nitrogen differs than the other elements. Clear ma? The first property here is p pi multiple bond. P pi multiple bond. Clear ma? So you know that here p pi means pi bonds here, multiple bond. Clear? Nitrogen, you know that because of its small size and high electronegativity. Clear ma? So nitrogen can form the p pi multiple bond, means pi bonds with itself or with the, you know, small size atoms and highly electronegative atoms. Clear ma? So nitrogen, what is the first one here? Nitrogen can form p pi multiple bond, p pi bond with itself and with small size atoms, and highly electronegative atom, highly electronegative atoms. Clear ma? So nitrogen can form p pi bonds with itself and also with the small size and highly electronegative atoms. Like you know, if you take the nitrogen is there, N2 molecule if you take, N2 molecule means how it will be ma? There will be a multiple bonds, p pi bonds, pi bonds. How many pi bonds are there in this triple bond? One sigma bond and two pi bonds, and these two pi bonds are formed by the overlapping of p orbitals here. So that's why p pi multiple bonds we will call those. How many bonds are there between the nitrogen and nitrogen atom? 3 bonds. So if you take the remaining other elements, they cannot form the 3 bonds here, but only nitrogen. Clear? And nitrogen can also form, you know, this p pi bonds with the small size atom, means, you know, cyanides, or you can say simply cyanide. What is the cyanide? C triple bond N. So nitrogen is also making p pi bonds or pi bonds with the small size atom like carbon, or also nitrogen can also make the pi bonds with the oxygen atoms. Clear? So that's why here nitrogen exists as a, because nitrogen can form the multiple bonds, so that's why nitrogen is exist as diatomic molecule. Diatomic molecules with which bond here? With triple bond. Clear? So this is with triple bond. But you know that these nitrogen molecules are held together by weak van der Waals forces. You know that nitrogen molecules, I am not talking about the nitrogen here. Nitrogen is between the nitrogen and nitrogen, triple bond is there. But if you take so many nitrogen molecules are there, then these nitrogen molecules are held together by which bonds here? Weak van der Waals forces. Weak van der Waals forces. Clear? So that's why these, due to the weak van der Waals forces are existed between the among the nitrogen molecules. So that's why nitrogen is a gas at room temperature. Nitrogen is a, what it is here? Gas at room temperature. Clear? And you know that if you take the remaining elements means what it is? Now phosphorus, arsenic, antimony, they do not form the p pi multiple bonds. Clear? So remaining elements, phosphorus, arsenic, antimony, bismuth, and do not form, or you can say cannot form p pi multiple bonds. P pi multiple bonds. Instead of these multiple bonds, they will form only the single bonds between the atoms. Like, you know, if you take the phosphorus, pp bond will be there, and here, you know, as bond, and here sb bond, like so. But bismuth will form the, you know, bismuth will form here metallic bonds. Clear, my dears? So it is there. So that's why these molecules are existed as a tetraatomic molecules. Phosphorus, arsenic, antimony exist as which one here? Tetraatomic molecules. Clear? So tetraatomic molecule means this is like structure: phosphorus, and here 4 phosphorus atoms are there, and discrete, you know, tetraatomic molecule. So you know all the phosphoruses are, you know, connected by which bonds here? Single bonds only. Clear? So this is about the first property which nitrogen differs from the other elements is p pi multiple bond. Clear? So next, second property, the nitrogen which differs from the other elements is catenation. Clear? So catenation. What is the catenation? Catenation means self-linking of atoms. Self-linking of atoms. Clear? That we will call as a catenation. Means you already know self-linking of atoms. So in the periodic table, which atom or which element will have the highest catenation property means, you know, the carbon. Carbon is what it is, 14th group element, that is the first element in the 14th group element, has the highest catenation property compared to the remaining all elements. That's why we can see here carbon compounds. Carbon can link, carbon can link together by, you know, so many number of carbon atoms. So that's why we will see C17H35 fatty acids are there, C17H35 COOH. We will say how many carbons are there here? 17 carbons. If C60 we will sometimes we will write Buckmiller polarine, that one also Buckminster polarine, that one also, you know, C60 we will write almost 60 carbons. Clear? Means here in the graphite if you take, so many carbons are held together. So that's why, and carbon have the highest catenation property, maximum catenation property shown by the carbon compared to the any other element in the periodic table. Clear? So, but we are talking about here, what it is here, nitro means 15th group elements. Clear? But you know nitrogen also first group element in the first element in the 15th group. It should also show the highest catenation property, but not. Clear? So among these 15th group elements, and phosphorus has maximum tendency for catenation. Maximum tendency for what it is here? Catenation. Maximum tendency for catenation. So which one should have? Actually nitrogen should have, because the first group means 14th group. If you say carbon has the maximum tendency for the catenation, nitrogen should have, but not nitrogen. What it is here? Phosphorus. Clear? Why means you already know that here. Means if you take the catenation means like it is phosphorus and phosphorus, they should attach together, linking, self-linking. If I take nitrogen and here suppose nitrogen, like if I write, clear? You know that the bond between these atoms, if strong, then they can link together by the so many nitrogen atoms and also by the so many phosphorus atoms. Clear? But you see, compared to the here PP bond, if you compare, and nitrogen NN bond compare. Clear? So PP bond is stronger compared to the NN bond. This is weaker. Why it is weaker? You already know. And here nitrogen is having lone pair of electrons, one lone pair of electron. Clear? And phosphorus is also having lone pair of electron, because it just assume here 3 bonds are there, lone pair of electron. So due to the and inter electronic repulsions of the lone pair of 2 nitrogen atom, because here repulsions between the lone pair of electrons will be there, and you know this is small atom and small atom, the bond distance is very short. And small atom means bond distance will be what it is? Very short, and these 2 nitrogen atoms are very close to each other. When they are very close to each other, and on these 2 nitrogen atom lone pair of electrons are there, they repel each other. To avoid that repulsions, you know, nitrogen atoms will move away from each other, then automatically bond length increases. When bond length increases, and it become a weaker. Clear? But compare here, you can say here also inter-electron repulsions are there, but you know nitrogen compared to the nitrogen phosphorus is, you know, larger in size. When they are larger in size, bond length between the phosphorus and phosphorus is larger than the bond between the nitrogen and nitrogen. If they are somewhat longer, you know, then lone pair repulsions will be less. So that's why this bond is strong. So that's why phosphorus can show the maximum tendency for the catenation compared to the which one? Nitrogen. But if you see the carbon doesn't have, you know, if I like so many carbons, you can see, and here nitrogen if I write 3. Carbon doesn't have any lone pair of electrons here. And 4 bonds are, this 4 electrons are utilized to form the 4 bonds. So that's why there is no electronic repulsions. There is no electronic repulsion means this bond will be very, very strong, because this is small atom, this is also small atom, and bond will be very strong. So that's why carbon has the highest tendency or maximum tendency for the which one higher? Catenation. So that's why, and which one will have the highest catenation, maximum catenation property means, you know, phosphorus. Clear? After then nitrogen, and now after if you are moving down, catenation property decreases. Why? Because size increases means bond length also increases between the molecule, so automatically decreases. So that's why what is the order for the catenation is here nitrogen, first one is phosphorus. Clear? PP bond, if I just write phosphorus, and after then you will get the nitrogen and arsenic, and after then, you know, they cannot link together. Why? Because size, if you go for the antimony and bismuth, size increases, when size increases, bond length also increases, bond length increases, this bond become very weak, so that's why, and they cannot show the any catenation property. So if you see the nitrogen can form the chain, clear ma? Phosphorus can form the chain up to the, what it is ma, 8 atoms, phosphorus atoms, up to the how many 8 phosphorus atoms ma here, 8 phosphorus atoms. But nitrogen form the chain, nitrogen form chain containing maximum containing up to 3 atoms, up to what it is ma here, 3 atoms. That is also hydrozoic acid. If you see, this is nitrogen and here there will be a nitrogen, clear ma? So triple bond positive charge, and here there will be a lone pair of electrons, clear ma? So this is hydrazine, clear ma? It is N3H. Here how many chain length here? Up to the 3. This is the another one property of which one ma here, catenation. So here you see we are showing some, it is some different behavior. It should have highest catenation property but not. So third one, clear ma? If you go for third one, and that is reactivity. Third property is what it is ma here, reactivity, clear? So reactivity, if you see, and you know that nitrogen is inert, it is almost inert. Why? Because you know which bond will be there between the nitrogen, triple bond. To break this bond, you know bond dissociation energy, clear ma? What is the bond dissociation energy? Bond dissociation energy for the nitrogen to break this triple bond, we required 941.4 kilojoule per mole. Means, you know, to involve in the reaction, what should this bond should break, then only it will involve in the reaction. To break this bond, we need so much of energy, so that's why it won't react easily, clear ma? So that's why almost we will say inert. But you know remaining elements, you know phosphorus, if you take, phosphorus will form which bond? Single bond. Single bond means what is the bond dissociation energy here? Almost 331 kilojoule per mole. Means if you apply less amount of energy, these bonds will break. When bonds breaks, then it will involve in the reaction, clear ma? So that's why phosphorus will have the high reactivity compared to the what it is ma here, nitrogen. So phosphorus has high reactivity than which one ma here, nitrogen, then what it is ma, nitrogen. And this is about the reactivity. And next one, if you go for the fourth property here, and maximum covalency, this is also very important. Maximum covalency, very important. This is also another one property, and nitrogen shows the nitrogen behave differently from the other elements is maximum covalency, clear ma? Because since small size and high electronegativity and absence of d orbital, nitrogen shows the maximum valency 4, that too when it donates its lone pair of electrons, clear ma? So what is the maximum covalency of nitrogen? Maximum covalency of what it is ma here, nitrogen is 4. What is my maximum covalency? 4. You know that nitrogen, if you take ammonia means what is ma, NH3. NH3 means nitrogen is forming how many bonds here? 1, 2, and here what it is ma, 3. Total how many bonds it is forming? 3. So you can say here number of bonds means that is covalency. So maximum covalency is here 3, but here what I said here 4. But you know that whenever nitrogen it is forming the 3 bonds, it is having one lone pair of electron. Nitrogen is having one lone pair of electron. So that's why whenever any suppose electron deficient species are there, it donates electrons to make a bond, then what happen here, and it will be converted into NH4 and plus. Now nitrogen is forming how many bonds here? 4 bonds. So that's why what is the maximum covalency? 4. That too when it donates its lone pair of electrons, then only it will show the maximum covalency is 4. Clear, my dears? So that's why you know and this is nitrogen cannot form the compounds like, you know, nitrogen, it cannot form nitrogen, clear ma? Nitrogen cannot form penta compound, pentahalides, you know, cannot form pentahalides, pentahalides like, you know, NCl5 and, you know, NF5, they cannot form here. NCl5 or NF5, they cannot form. Why ma? To form here, how many bonds nitrogen should form? To form this compound, nitrogen should form here 5 bonds. But what is the maximum capacity of the covalence of the nitrogen? 4. It cannot form the, you know, it cannot extend its covalency beyond the 4. Clear ma? Because of which one? Because of, they very important, because of absence of d orbitals. Because of what it is ma? Absence of d orbital. Because of absence of d orbital. Clear ma? D orbital means, you know that, and it is having ns2 np5. This is 2 electrons here and here 3 electrons. Clear ma? Now 3 single electrons or unpaired electrons are there and they involved in the bond formation. So that's why they will form how many bonds ma? Here 3 bonds here. 3 unpaired electrons means nitrogen will form how many bonds? 3 bonds. Clear ma? And it will form 4th bond when it donates its lone pair of electrons. Clear ma? But here NCl5 to obtained, nitrogen should make a how many bonds? 5 bonds. 5 bonds means if there is a d orbital, if there is a d orbital, then what will happen? This one of the electron will jump in the d orbital. Then how many single electrons will be there? 5 single electrons are there. Then they can form the 5 bonds. But because nitrogen doesn't have the d orbitals, so that's why it can form only what it is ma? 4 bonds. But if you take the remaining elements, they can form how many bonds ma? Here 5 bonds are maximum covalency. If you take the phosphorus and arsenic, clear ma? And has, you know that covalency decreases down the group, because, and bismuth will show the mainly bismuth tri compounds are, you know, stable compared to the penta. So that's why I am writing here phosphorus and arsenic has maximum covalency, what is ma? 5 and 6. Why? Because they have the d orbital, empty d orbital. So that's why they can extend their covalency and 5 and also 6. If you take the simple example, suppose if I take PCl3 and it is treated with the chlorine, then what the compound you will get? PCl5, because phosphorus can form how many bonds? 5 bonds. Clear ma? So this is about the another one property nitrogen differs from the other element is covalence. Maximum covalence of nitrogen is 4, that too when it donates the lone pair of electron, but remaining element will show the maximum covalence up to the 6. Next, another property is d pi p pi multiple bonds. Means you don't think it is somewhat different here. D pi p pi means here pi bond will be formed. One atom will use the d orbital, another atom use the p orbital to form a pi bond. That we will call as a d pi p pi multiple bond. Clear ma? So you know that nitrogen, because absence of d orbitals, nitrogen cannot form the d pi p pi multiple bonds. Clear ma? That is the first point. Because why? To form the d pi p pi multiple bonds, and that atom should have the which bonds have which orbital should be available here? D orbital. But d orbitals are absent in the nitrogen. So you know that here, because nitrogen cannot form d pi p pi multiple bonds, d pi p pi bonds, b pi bonds, because of absence of d orbitals. Clear ma? Absence of which orbitals ma? Here d orbitals. Clear ma? So that's why if you see this, so that's why nitrogen cannot form here R3 triple bond n type compounds. Clear ma? Or if you take R3n double bond CH2 type. Clear? And next one is R3. Suppose if you take suppose some X3, I can write here NO some X3. This type of compounds nitrogen cannot form. Why? Why means you already know that here to form this, nitrogen is forming how many bonds here? Here nitrogen, see I will write in this way, R and here R double bond. Nitrogen is forming how many bonds here? 5 bonds. Maximum covalence of the nitrogen is how much ma? You know maximum covalency is 4. Clear ma? To form a next bond, you see, suppose just assume, and here NS2, 2S2, what it is ma here? 2p3, and here 3 electrons are there, and here 2 electrons are there, and here you know all are unpaired electrons. When unpaired electrons are there, they are involved in the bond formation. Just assume these 3 are formed due to the utilizing of these 3p electrons. Clear ma? And it can form, you know, one single bond means, just assume here by donating its lone pair of electron, one is formed. Then what about the fifth one? Here pi bond should form. Clear ma? 5 bond means, can it form pi bond? No, it cannot. Why? Because next there is no orbital to make a fifth bond for the nitrogen. So that's why it cannot form what it is ma here, d pi p pi bonds. But if you take the other elements like phosphorus, mainly what it is ma here, phosphorus. Phosphorus can form the d pi, phosphorus, arsenic, antimony, they can form the d pi p pi multiple bonds. Clear ma? So next point is here, phosphorus, arsenic and antimony can form d pi p pi multiple bonds. D pi p pi, what it is ma? Multiple bonds. Clear ma? So that's why we know this phosphorus means this is oxide, phosphorus oxide, and you know this is phosphorus double bond CH2. Phosphorus oxychloride we have already studied. This can be these compounds can be formed by the phosphorus, but not. Why? Because you know that in this one 3s2 3p3, 3s2, what it is ma here, 3p3, 1 2 3, and phosphorus will have also empty d orbitals. Clear ma? So that's why one of the electron will jump here. How many single unpaired electrons are there here? How many unpaired electrons are there? 5 unpaired electrons are there. It can form the 5 bonds. You see, suppose these 3 electrons are used to form the, suppose I will write here R and R. Clear ma? These 3 electrons are used to form these 3 bonds, and 1 electron is formed to form a single bond between the phosphorus and oxygen, and this 1 electron is there. This is which orbital? D electron. D electron means it is making phosphorus, oxygen will have the which orbital? P orbital. Clear ma? And here oxygen will have the p orbital, phosphorus will have the which orbital? D orbital. So that's why, and phosphorus use the d orbital and oxygen use the p orbital to form this pi bond. So that we will call as a d pi p pi multiple bond. So that's why, and here phosphorus, arsenic, antimony can form the d pi p pi bonds, but not the nitrogen. What is the reason? Means because of absence of d orbitals.